Now, in this video, we are going to see the different methods of data transfer. In previous videos, we have been talking about I/O interface and what is how actually the I/O operation takes place. So there again, you have a source and a destination. Okay, a source unit and a destination unit. The source unit can be a CPU and the destination can be memory or it can be I/O and vice versa. So the source can be I/O, input can come from any I/O device and destination can be CPU or it can be memory. So, but anyway, whatever be the two units, there is a data transfer that is happening from one unit to another unit. That is what we were seeing in the previous videos. So here now we will talk about how the data, what are the methods in which the data transfer occurs. So there are two methods. One is called synchronous and the other one is called asynchronous. So what do you mean by synchronous? Synchronous is all operations, internal operations in a digital system that are synchronized. Okay, so synchronized in the sense everything happens simultaneously in a proper way. Okay, by means of clock pulses. So you have a system clock which generates some clock pulses, and on the occurrence of the clock pulse, data transfers. Okay, from one register to another register, from one place to another place, and this is called as synchronized. So you must have seen some circuits. Every circuit has got a clock pulse. Okay, so the data will get transferred only when the clock pulse occurs. So only that is called a synchronous data transfer. So the internal operations in a digital system are synchronized by means of a clock pulse supplied by a common clock pulse generator. So within one unit, let's say one unit is CPU. So within CPU, there may be so many registers. So we know there are general purpose registers, there is an accumulator. Okay, and we have seen a lot of registers. So data transfer among these registers will happen based on the clock pulse. Only when the clock pulse, the pulse is supplied, clock pulse occurs, the data transfer within one unit happens. Okay, so this is called synchronous transfer. Whereas now we are talking about two units, data transfer between two units. One unit is your CPU and the other unit is your IO or your memory. Okay, so this each unit will now have different, it will have internal timing on its own, independent internal timing, which means it might have its own private clock. Okay, so but data has to be transferred, okay, based on these two independent units. So which means the clock pulse in one unit will be different from the clock pulse in the other unit because they are being generated by two different private clocks. Okay, so but data has to transfer from one place to another. So here, along with the data, some other control signal has to be transmitted for the data to be properly transferred from one place to another. So that is called as asynchronous transfer. So asynchronous is mostly the internal timing in each unit is independent from each other, meaning each unit will have its own private clock. Asynchronous data transfer between two independent units requires that control signals be transmitted between the communicating units to indicate the time at which data is being transmitted. Now, there are two types of asynchronous data transfer methods. One is called the strobe pulse and the other one is called handshaking method. Okay, now we now have to understand that in an asynchronous data transfer, okay, the transfer within one unit is synchronous. Data transfer between two different units, two independent units are always asynchronous. But there can be synchronous data transfer also between the two different units. But that is not what we are going to see. We are going to see asynchronous because mostly in most of the systems, asynchronous data transfer is what is followed. So here we are going to see only asynchronous data transfer. So here we will, as far as synchronous data transfer is concerned, data within one unit. Data transfer within one unit will happen synchronously, and data transfer between two units will happen asynchronously. Okay, so when it has to happen asynchronously, along with the data, there has to be some additional control signals to be transmitted to indicate the time in which the data will be available. Okay, or the data valid data is available for transmission. Okay, now there are two types of asynchronous data methods, data transfer methods. One is strobe pulse, the other one is handshaking method. A strobe pulse is nothing but I told you some control signals have to be transmitted. So strobe pulse is one control signal, so which will be supplied by one unit to indicate to the other unit that a valid data is present in the data bus, and you can the source, there will be a source unit and there will be a destination unit, and along with the data bus there will be a strobe pulse also. So the strobe pulse will be supplied along with the data to tell the, and the source will tell the destination, or the destination might tell the source that the valid data is present. So to indicate a valid presence of valid data in the data bus, the strobe pulse will be supplied, and this will be a single direction. Okay, a strobe pulse will be initiated only by one unit. Okay, only by one unit, and one unit where the transfer is happening between two units. So this is strobe pulse. But handshaking is there will be two signals. Okay, one control signal is accompanied with each data. Okay, each data to indicate the presence of the data, and the other control signal will be from the receiving unit, acknowledging the receipt of the data. So there will be two signals in handshaking. So handshaking, when can we have a handshake? Only when two people meet and they shake their hands together. So this is exactly what is called. So handshaking means that two people. I mean, when I say two people, two units. So when data is being transferred between two units, the first unit will send a pulse, will send the data along with a pulse, with a control signal saying that there is a valid data, and the other unit will respond back with the acknowledgement pulse saying that the data has been received. So this is called as handshaking. Okay, so these are, in strobe pulse there will be only a single control signal, whereas in a handshake there will be two control signals. Okay, so now the advantages, we definitely we can from this itself we can understand that handshaking is more advantageous than the strobe pulse. Okay, so we will first see what is strobe in detail, what is strobe control. Okay, so in a strobe control, strobe control always employs a single control line, okay, to time the transfer. So this strobe control can be activated by either the source or destination. So here I have given two diagrams, two timing diagrams. Okay, one is source initiated strobe for data transfer, and another one is destination initiated strobe for data transfer. Now look at the block diagram. So you have a source unit. Now the source initiated, an example for source initiated strobe for data transfer will be a memory write instruction. So the source might be your CPU and destination will be your memory. Okay, so which means it's a write instruction. The CPU would want to write some data into the memory. So the source is your CPU and memory is your destination. Okay, there is a data bus, and along with the data bus there is a strobe pulse also. So what happens? Look at the timing diagram. You have the data. The data initially will be in low impedance. In low impedance means it will be in zero, and then when valid data is placed, okay, it goes from low to high impedance. Valid data is supplied. So initially you will see that the data will be first. The data will be placed by the source unit And after a delay, after some time, after a few milliseconds, the strobe pulse will be placed, will be activated or enabled. The reason is the data has to be placed, it has to settle in the data bus. So it will the source unit will give some time for the data to valid data to get settled in the data bus, and then it will give the strobe pulse saying that valid data is present in the data bus. Okay, so then you will see that the destination unit will transfer the data into its register and during the falling edge. So we know that this is the rising edge. In a timing diagram, from 0 to 1 is called a rising edge, and from 1 to 0 is called a falling edge. Okay, so this is a rising edge and this is the falling edge. So the falling edge will happen after some time. Okay, so giving time for destination unit to transfer the data from data bus to its own register. Then during the when will it get transferred? During the falling edge of the strobe pulse, the data valid data from the data bus will get transferred to the internal register of the destination unit. So this is how the source initiated data transfer will happen. Now let us see the destination initiated strobe for data transfer. Now destination initiated will be a input instruction. So the source will be memory and destination will be CPU. The CPU now wants to read some information from the memory. So the source is memory and the destination is CPU. So now the CPU is requesting some data from the source unit. Okay, source. So the pulse here is generated. The strobe pulse is generated by the destination unit, and you will see the data is placed by the source unit only. Okay, so the strobe is placed by the destination unit. Now look at the timing diagram. It will be exactly opposite. So here in the source initiated, the first valid data will be placed in the data bus, and after a delay the strobe pulse will be enabled. Whereas in destination initiated strobe, then you will first the strobe pulse will be initiated, because the strobe is actually a request from the destination unit for the source unit to place the data in the data bus. Okay, so it will ask for valid data, and then the source will then place the data. So that is why the strobe pulse will first be enabled, and then valid data will be placed by the source unit, and during the falling edge of the strobe, the valid data will be transferred from the data bus to the internal register of the destination unit. So this is destination initiated strobe for data transfer. Okay, so this is about your strobe control. Now, what are the drawbacks of strobe control? Why should we go in for a handshaking method? So the strobe method, during when it is a source initiated strobe method, the source unit that initiates the transfer has no way of knowing whether the destination unit has actually received data. Okay, see, if you look at this diagram, the in source initiated strobe transfer, so what happens is the valid data is placed by the source unit, and then a strobe pulse is enabled to inform the destination unit that a valid data is present. That's all. But there is no way for source unit to know whether the data has actually reached the destination unit. Similarly, in destination initiated strobe, the destination has requested the data from the source unit by initiating a strobe pulse. But the source will place a valid data, and the destination, there is no way for the destination to know whether the source has placed valid data in the database. So because there is only one signal, the strobe signal, a single control line in this method. So this is the drawback of source strobe methods, whether it is source initiated or destination initiated. So to solve this problem, we go in for a handshake method, where a second control signal, which is called a reply signal or an acknowledge signal, is is also initiated. So let us see the block diagram of source initiated transfer using handshake. So you will see that in the block diagram, you have the source unit and you have the destination unit. So along with the data bus, you have two control signals now. One control signal is a data valid signal and the other one is a data accepted signal. Okay. So you will see that the again the same example where it's the source unit places it's a the write instruction. So the source is CPU and the destination is memory. So the source CPU is trying to write some data into the memory unit. Okay. So it places some data in the data bus. So first data is placed in the data bus and after a delay the data valid signal is enabled, informing the destination unit that valid data is placed in the database. Then after some time you will see that once when the destination unit has accepted the data from the database, it gives another signal. Look at the direction of this signal. It is from the destination unit to the source unit. So this the destination unit now initiates another signal which is called as data accepted signal, informing the source that the data has been accepted by the destination unit. Okay, so this is the timing diagram for this will there will be a complete sequence. In the sense the source unit will place the data in the data bus and it will tell the destination unit that valid data is present. Now destination unit will start transferring the data to its internal register. Once when it starts accepting the data, it will send another result. It will acknowledge the acceptance of data to the source unit by giving a data accepted signal. So the process is now complete. The cycle is now complete. Okay. So that is the advantage of using handshake transfer. Now look at the sequence of units. Place date. So from the source unit, so place data on bus, enable data valid. And then it go from there, look at the arrow mark. Accept data from, so destination unit will accept the data from bus and then enable data accepted signal. Then from there, once when data accepted signal is enabled, so the source unit will disable the data valid signal. Okay. So here you will see that data valid signal will the falling edge is somewhere here before the falling edge of data accepted. So first the data valid signal will be disabled and after some time the data accepted signal will be disabled. So disable data valid and invalidate. Once when the data valid signal is disabled, then it means that there is no valid data in the database. That is the meaning for it. So disable data valid, invalidate data on bus. And then what does the destination unit do? It disables data accepted and now it is again ready to accept data. It goes to the initial stage. So it goes back to the starting position. So one set of data will now be transferred. Now the destination unit is now ready to accept the second set of data. Once again, the source unit will place data on the bus, enable the data valid. Same thing, the cycle now continues until full data is transferred from the CPU to the memory. Okay, in case where the CPU is your source unit and your memory is your destination unit. So here what happens, the advantage of this is it allows arbitrary delays from one state to the next. Okay, when the source and unit, when there is a the delay in transfer, so what happens is the one unit will just wait for some time till the full data. See, the data accepted will be disabled only when only when the full data has been accepted. Okay, so that can be some delay. Okay, so and the possible delay can now be tolerated by the source unit. Okay, and permits each unit to respond at its own data transfer rate. When two different if in case if the transfer is happening between CPU and IO, we already know that IO is very slow and the data transfer rate is very much slower. So then in that case, the CPU has to wait till the data has been completely transferred to the destination unit. So the rate of transfer is determined by the slower unit. So the transfer can happen continuously, and the source unit can wait till the data has actually reached the destination unit. Whereas in the previous method in strobe, valid data will be placed and it will just inform the destination that valid data is placed, and there is no way to know whether the destination has actually received the data. Okay, so that is why this method is much better than the previous one. Now the next one is we are going to see the destination initiated transfer. So here again you have the destination unit and the source unit. So first the destination unit will now request for, it's again an input instruction. So source unit is your memory and destination unit is your CPU. So CPU now initiates a read instruction or an input instruction. It says it places a ready for data signal. Okay, then so that is the first one. So ready for data signal will be enabled first. Okay, and then the source unit will place the data in the data bus, and after a delay it will enable the data valid signal. Okay, then after some time, the once valid data is placed, the destination unit will disable ready for data signal. Okay, because and then the data will be transferred, valid data will be transferred to the destination unit. So this is the sequence. Now look at the sequence. We will start from the destination unit. So it will ready to accept data, enable ready for data. Then from there, arrow marks, then from there, look at the source. The flow starts from the destination and then comes to the source unit. So it places, the source unit places data on bus, and then it enables the data valid signal. Then after some time, the destination unit will accept data from bus and disable ready for data. And then the source unit will disable data valid, invalidate data on bus, and again goes back to the initial stage. So one set of data will now be transferred from the source unit to the destination unit. Okay, so the handshaking provides a high degree of flexibility and reliability because of successful completion of a data transfer, because there is active participation of both the units. I told you the cycle is complete. Okay, so because of that, the handshaking provides high degree of flexibility and reliability. And if one unit is faulty, there is some error in the let's say data transfers from, so let's say the data has to go to the output unit, which is your printer, and the printer is not switched on. Okay, so what will happen? The CPU will wait for some time. There will be some delay. It will wait for some time, and after some time, there will be a maximum time that the CPU can wait. Okay, it will wait for some time, and there will be a timeout mechanism. There is a timeout mechanism there. So internally, the clock will be set so that the CPU can wait only for certain amount of time for the IO device to respond. Okay, so after that time is elapsed, then what will happen? It will throw an error message saying that the IO device is not ready or something like that. Okay, so this is destination initiated transfer using handshake. So in both the in comparison with both the methods, the handshake method of data transfer is much better than the strobe one.